Learn to create an action game in Unreal Engine 5 at unfgames.com. Have you ever wanted to add a hookshot in your game? Hello y bienvenidos. A hookshot is a game mechanic that usually helps the player navigate the map and give them access to new locations. And in this video, we will develop a simple hookshot mechanic inside Unreal Engine 5. I will cover the logic side of things by using blueprints, enumerators, and blueprint communication, but also the graphic part of the hookshot by importing some Quixel assets. At the end, I'll add some game dev secret sauce to make our mechanic feel more complete, so make sure you watch until the end. I hope this tutorial is a great learning experience for you, as it was for me. With that said, let's start! The first thing that we need to do is create the project. Games, blank, and as a name, mechanic hookshot. Create, dismiss this message, create the necessary folders. I'm creating one folder with the name of my project, and inside it, I will create anything that I need regarding this project. I'll create a core folder, and inside it, I'll create a folder for the framework, because we are going to be using a correct structure for this project. So inside the framework, I will want to create a game mode that I will be using for my project. So the name will be the same as the project. And if I want every level to use this mechanic hookshot, I can click here, game mode, and it says project settings here, and select a game mode. I will use the game mode mechanic hookshot. This is the same as opening the project settings, here in settings, project settings, and going to maps and modes and assigning it here. It's the same thing. Now, something that I did when I paused the video was add this plugin. You really don't need to add it. I'm just adding this plugin, Blueprint Assist, that I bought from the marketplace, because it's a way of creating blueprint without using the mouse too much, and also it assists me in reorganizing the nodes, so I don't need to waste too much time on that. So just as a little warning, if you see that my blueprints, that my nodes are reorganizing themselves automatically, it's because of this plugin. Now, the game mode has a lot of uses, and one of them that we will be taking advantage of is defining the classes that will be used by default. This includes the pawn that will be used by default. A pawn inside Unreal is any type of actor, and as a reminder, actor is anything that can be inside of the level. Any kind of actor that can receive input and can operate and translate or do something with that input, it's called a pawn. In our case, any character will be a pawn. So I want to define the default character that I want to use. So first I need to import one. I'll click here on add. I'll click add feature or content pack, and I'll select the first person template. I'll add to the project, and here I have it. Here I can find the first person character that I'm going to use, and I can close this window. I'll open the first person character and I'll close this window. Now, if I want to press play and use that first person character, I need two things. The things that I need are first setting it up in the game mode. So I'll double click my game mode, and here you can find the the default pawn class. If you're not seeing it like this, it's because this is the data only blueprint that sometimes it shows if you create a game mode and you don't modify anything. Or well, if you create any blueprint and you don't modify anything, you will see this window. But I will click on open full window. This is probably what you have if you just created the game mode. And you can click on class defaults. And here, default pawn class, I'll select my first person character. Now, inside my map that right now is untitled, that I should probably save, I need to add a player start. Otherwise, when I press play, the character will start wherever my camera is at the time, like this. So I want to start at the middle for now. I'll click here on player start. There we have it. And it's always going to start in that point of the map. Let me also save the map. Save current level as. Go to my mechanic hookshot. Inside, create a new folder called level or maps. Maps is more standard. And here I'll put test map. Okay, the map is saved. And the last thing that I want to do with my folders is right click my main folder, the mechanic hookshot folder, and give it a color so it is a lot easier to know which of these folders is the main one. Well, the main folder that I will be adding content to just at a glance, right? I see, oh, what's this color? That's the folder that I'm looking for. Now that we have set up the project correctly, we will start working on the hookshot mechanic. For that, here, because the hookshot will be a core mechanic of my game, inside the core folder, I'll create a new folder called hookshot, where I will store everything related to the hookshot. For example, I'll right click and create a blueprint class, an actor, and call it blueprint hookshot. And I will also open it. I can close the game mode now because I'm going to be working with these two blueprints, the first person character and the blueprint hookshot. Let's start with the base logic. The first part of the logic is creating an input, so whenever I press a button, I can use the hookshot. Right now, the left click can use the gun if you pick it up, but I always want to have the hookshot in my character, so I will not be using the existing logic here. First, let's create the input. Let's go to the project settings. If you don't have it, you can also go to edit, project settings. And in the project settings, I'll go to the input. I'll press on action mappings, and I'll create another type of action, which will be use the hookshot. Right now, the primary action is left mouse button. So in this case, I'll press this keyboard button and right click. And now I have the right mouse button. You can also search it here, but it is easier this way. Now in my first person character, I can right click, type input, use hookshot, and we will have this input action. We have input action and input axis. Input actions are specific actions, like for example, pressing jump. You want to know when the key is pressed, and you also want to know when the key is released. Now the axes are a little bit different. They are mostly used for movement, and we have here look up, down, or move forward, move backward. The input is different because I will only see that it's always firing and always getting this axis value. So it is a continuous type of action. Very useful for the mouse, very useful for movement. Now with this use hookshot, I should probably start doing something with the hookshot. Here in the blueprint hookshot, I want to have something that can represent it for now. So I'll just create a new component. I'll add a static mesh. And because I don't want it to be completely empty, I'll put a sphere there. This sphere, I'm going to remove the collision here in the details panel. No collision. And for now, let's scale it a little bit. Here in scale, click on the lock. So whenever you modify one, the other ones are modified as well. So let's unlock it, compile and save it. And I want to add this blueprint to my first person character. I will go to the viewport, and in the component panel, I'll click add. I'll click child blueprint. That if you can't find it, just type child. Here, child actor. And this child actor will be the hookshot. Here in the child actor class, I'll select the blueprint hookshot, and it should pop up here. Now I can move it near my hand, and when I press compile, save, and play, I will see that I have this hookshot blueprint in my hand. Not exactly in my hand, but at least it's in front of me. We will later on will correct this. So don't worry, let's just make it work like this, and then we can polish it later. Now, when I click and fire this use hookshot event, what I want to do is do a little line trace. Now, in this test map, we don't have much stuff. So let me add a little bit of cubes. For now, something very simple. Yeah, that works. So, a line trace. That's what we need to do whenever we click and we want to use the hookshot. What is a line trace? A line trace is just what it sounds. We will do a trace of a line. We need to define the initial point, which will be the character, and the final point, which will be in a direction that we are looking. Could be here, could be like this. It all depends on the length that the chain of the hookshot will have. Now, that line trace will give us a lot of information, because if the length of the chain is something like this, then here it will not detect a hit, but in this other case, it will detect a hit here. And now we know where do we need to place our hook of the hookshot, and where should we place our character. Now, the first part of the logic has to do with creating this line trace and knowing where to place the character, creating that movement, and well, positioning the character. So let's do that. What we're going to do here is whenever we use the hookshot, we want to make sure that we have a hookshot. So this child actor, I'll get it, and I will cast it, and that's cast it to the blueprint hookshot. Now, this is a very common mistake whenever you are starting to work with child actors. It's a child actor, but here it's a child actor component. This component has inside it the blueprint class that you have defined, so you can't cast this component to an actor. You first need to get the actual blueprint, so I'll get blueprint, or was it child? Here it is. Get child actor, and this reads the actual value of the actor. And just so I don't confuse myself with this, I should rename this to hookshot actor component. Or, well, it would be better if it's just child actor. Now, from this component, I'm getting the actual blueprint, and this blueprint, I can cast it to my blueprint hookshot. Now, I will connect it to the pressed. So, this pressed execution pin, we'll first do a little cast on top of our hookshot child actor. A cast is just a way of translating to Unreal what are we expecting to get from this child actor. Why? Because right now this is an actor object reference. And if I had information inside my hookshot, like for example, if it's in use or not, if I drag from here and I ask for a variable inside it, that we can create a variable very quickly. Let's just create a variable called new variable 0. Here, if I type get new variable, there is none because this is an actor object reference. Now, my blueprint actor inherits from an actor object reference. So here, if I just tell it get new variable, we can get the specific information that we have put here. How do I know that this blueprint actor inherits from an actor? Because if I click on the blueprint, here I can see the parent class. That it's what we did whenever we created a blueprint, like we just right click blueprint class, and here we are choosing the parent class. That's why I chose an actor. And again, an actor is anything that can be put inside the level. Okay, so now we have complete certainty that the hookshot can be used, that this child actor is actually a hookshot actor. So now we just need to call our logic for that line trace. And I will do it here, but later on I will put it inside a hookshot because I would like my code to be very modular. Being modular means that anything that I put here, I can reuse it in another class. If I put all the logic inside this first person character, whenever I change character, then I will need to copy and paste whatever I put here. So let's try at first the simple direct way, and then we will put it inside the hookshot. The first node that I need to use is the line trace. So here, line trace. You will see that there exists line trace and multi-line trace. And the main difference is that this line trace only returns one value. And the multi-line trace returns all the values that has collided with this trace. In my case, I do not want my hookshot to go through stuff. So I only need to worry about the first hit. If you had bullets that can go through walls, maybe you will want to have a line trace, a multi-line trace. Now, I will be using line trace and line trace by channel because it will be easier to set up a channel also for my hookshot. And we will see that in a minute. Let's just start by setting up this part, and then we can mess around a little bit with the trace channels. So perfect. We need a start point and an end point. The start is pretty simple. We need where is my hookshot located, the actual blueprint. So from here, I'll get the actor location, and I'll connect it to the start. Now we need an end location. And for this part, I need to know where I'm looking towards, because my end location here, if I'm looking upwards, it will be around here, right? Like this is my start location and it will be around here. If I'm looking downwards, then it changes completely. So for that, I will be needing to use the actual camera. So I'll get the first person camera, and I want to know where it's looking towards. So I'll ask for its forward vector. Get forward vector. We have it here. And now this forward vector, I need to add it to my location. But let's keep in mind that this forward vector is a unit type of vector. What does unit mean? Is that the length of it will be 1. This is a vector. This is a vector going in the same direction. If I'm talking about direction, I really don't need to know if this distance is like maybe 20. I only want to know the direction. So Unreal does something, it's really a mathematical thing where we get the magnitude, or well, the distance, the length of the vector, so this becomes 1. Now, because this is 1, the distance, we do need to multiply it by the actual length of the hookshot. So for now, let's just multiply it by value, and I do not need a vector here. I'll just right click, convert pin, float single precision is more than enough. And for now, let's say that my length of the chain is 2000. Now, I do have a vector in the right direction and with the right distance or magnitude or length. Now, I need to do an addition with this actor location. So I'll add here. And I need to add this value with the actual starting point. So that way, I'm not using the 0, 0, 0 coordinate location. So what this is doing is we have the actual actor location. That is, let's start from the bottom. We have the camera, right? The camera is looking this way. I'm multiplying this value by 2000. So now the new value, it's like this. But this is being taken in account from coordinates 0, 0. So here will be 0, 0. This is the 0. And excuse my 0. 0, 0. We have a starting point, which could be anywhere here in the graph, could be here even, or here. So we are just adding this so we can use the vector like this. And that should give us the real result. That's the only thing that we are doing. And I'm pressing F with this plugin so it can auto accommodate stuff for me. So now we have the same. And it made it a little bit more confusing, so I'm going to connect it like this. That's how we had it. Perfect. Now, if I want to see what's happening with the line trace, actually, I want to go to draw debug type, and I'm going to put it as persistent. Or for duration. For duration, we'll take in account this draw time, so it's 5 seconds is more than enough. Persistent, it leaves it forever. Let's press play. And whenever I right click, I have this new value. And whenever it collides with something, remember that it's starting from this actor, that sphere. Whenever it collides with something, I can see where the collision happened. Which is pretty nice. Pretty nice. If I wanted to test if this location is correct, what I first need to do here is see if I collided with something, which this return value gives us. So here I'll press if, and now I'll connect this. And if this is true, I want to teleport my character to a destination location or something like that. Where is this location? Here we have another output pin, and if we drag and drop it and call break, here this break hit result will give me a lot of information about the hit that already happened. And here I'm checking if the hit actually happens. So here is the impact point of the location. So let's use it for now. If I click, I didn't hit anything, so my teleport doesn't happen. If I hit something, then my teleport does happen, because I'm hitting that part. The thing about this is that there is a little bit of an issue. And this will be more noticeable when we add the actual movement of going towards it instead of teleporting it. If we hit, and let's say that our character, where is our first person character? Blueprints. That our character is here, which is on the arms. And I use the hookshot hit here, and the teleport location, it's in this part of the map. Right, we should teleport there. But the main issue with this is that the way you're teleporting is, look at the pivot point or at the center point of this character. It will be matched here. So I'm going to teleport overlapping a solid object. And most of the times Unreal can calculate it by itself, and it will push me to the other side. But if this object was a little bit bigger, it could also push me to the inside. And we don't really want to have that kind of logic that sometimes it works correctly and other times it doesn't. We want to do something very consistent. So in order to acquire that consistency, we need to do another trace. And this time we need to do a trace that is very similar to the collision of my character, which is a capsule. This is called a capsule component, and I want to do this following logic. So whenever I collide here, I will get the direction. I will take a step back, maybe to 200 units here, just enough, and I will do a capsule trace from this point to the impact location. This will mean that I will draw a capsule, and this capsule will move forward, and will move forward like this, like this, like this, and there will be a point where the capsule collides with whatever thing we wanted to attach. But this capsule, and let me delete one of the drawings. Let's say that the capsule managed to collide here at this point. This capsule will have also this impact point, but also a location, which is the location where we can put the capsule without it overlapping anything else. So the location of this part will be here. So that's the main difference also, if we have here an impact point and a location. Like it says here, location of the hit. In word space, if this was swept shape test, like a capsule trace, this is the location where we can place the shape in the world where it will not penetrate. And that's what we want. So for now, let's just delete this teleport. And after it collides with something, what I want to do is do a capsule trace here. And again, I will only worry about the first collision, so I don't need a multi-capsule trace. Again, by channel, visibility, and now here as an start location, I need to find out that place where I step back. Like I say, the end location will be the actual hit, and the start location will be that maybe 200 units that worked fine in my tests. 200 units backward in the direction of that line trace. So it's easier to start with the end. The end is very simple, it's the same impact point. But the start gets a little bit more complicated. I need to know the direction between this start position and this end position. So let's just get unit direction here from to the end, and I just need to multiply this direction towards outward. So again, this is a direction. I want a magnitude, a distance, a length. So I need here a scalar value, which is only one number. This will be 200, and I'll connect this to the start. But first, I do need to, that's the same way that I did here, that I add it. But in this case, I want to take a step backward, so I'll subtract. I'll subtract from the actual point that I have as a reference. So here, I'll just subtract, and is this impact point minus whatever I had here. And I'll connect it to the start. So if I make a little bit of room, this will be something like this. So we have a start value, we have an end value. We need a radius. The radius will be the same one as my capsule component. So I'll get the capsule component. I'll drag and drop from here and get the radius. There is an scaled capsule radius and an scaled capsule radius. The unscaled capsule radius will be always the same, but if we choose the scale one, if for whatever reason my character gets scaled up or down, then this will be taken in account for the actual radius. So I will use the scaled capsule radius. Maybe there's a power up where you make the character go bigger or smaller. We need the half height. The half height is if the radius was this part, the capsule half height is this part. Now the radius, remember, is half of the actual circumference, so it's this one. And the half height is the same, but for the vertical part. So again, capsule component, get half height and scale capsule half height. I'll connect it to half height, trace channel visibility, and draw debug. I'll draw debug for duration. Now let's see what's happening. If I press play, if I click here, now I get a new type of trace. And that's exactly what we need. Now that we have this solved, we have we should have an actual position where we can put the capsule, and this is the position, without overlapping anything. Now if this value is too short or too small, you can increase it, but usually this is more than enough. Now we could use the teleport now, here, break the hit, and use the location. And now it will always give me some space where I don't need to worry too much with the actual with being too near the actual mesh. So I'm not overlapping anything. The last thing I wanted to mention here is here in the capsule trace channel, visibility. This is fine. By default, you can see the visibility channel if you go here and instead of lit, you try visibility collision. So most of all of the stuff are using this visibility collision. But if we didn't want to collide with something, for example, in the other line trace, here the hookshot is using that visibility. So let's say that we didn't want to collide with this. We could change its visibility channel to another value, but it wouldn't make sense. So it will be a good practice if you go to the project settings, go to the collision tab, and create your own trace channel for the hookshot. So let's create one, new trace channel. The default response will be block, and let's call it hookshot. Accept. Let's go back to my first person character. If I try to select it, I would not find it, so I need to compile first. And now I can select hookshot in the line trace. In the capsule trace, leave it as visibility because we are trying to collide with anything that could overlap our character. But here I only want to collide with anything that it's blocking the hookshot. Because we put it as block by default, everything will be working the same way it was doing before. But now if we go to the test map and we want to modify the hookshot channel of this object, we can click it. We can search for the collision category, collision presets. Instead of default, let's put custom. And the way that the Unreal collision system works is very simple. Here I have collision channels, collision responses, trace responses, hookshot. If two objects will have a collision, will actually block themselves, both objects need to be in agreement. In terms of the traces, it's a lot more easier because I only need this object to define if it will block that trace, if it overlap it, or if it will ignore it. If we put ignore or overlap, then whenever we click here, it's fine. But if we click that, oh, it wasn't this cube. Which cube was it? This one? This one. If we try to trace through this cube, we can't. So that way we can define which objects we want to actually work with a hookshot. So collision presets, I'll just return it to whatever it was. It was block alt or just default. And we can press play and everything will be the same as it was. Also because the line trace seems to be working, or well, the capsule trace that I don't really need anymore seems to be working, I'll be removing the draw debug type. I will put it to none. With the line trace, I still want to show something, so for now I will leave it like this. Let's continue. Now let's clean up a little bit of the code, and this cleanup in later stages, you will see that it makes the code, well, first modular, cleaner, and most importantly, more efficient. So these traces should be inside of my hookshot blueprint that I believe I closed it in some part of the video, but I'll press Ctrl P, blueprint hookshot, and I can open it very fast this way. Perfect, I have it here. Now, the result of these operations is to get the actual location where my character should be. So what I'm going to do is right-click this location and promote it to a variable. This will be called end location or end character location. And this should be between these two. That way, here in the teleport, I could use the end character location. I drag and drop on top of the node, and there I have it. Right. So all this code could be inside a function inside my hookshot. And that's what I'm going to do. Here in the hookshot, I'll create a function and calculate hookshot hit. Now, here inside it, I'll drag and drop everything. Well, not drag and drop, select everything after this. Before this, excuse me. Copy it. Oh, and just to mention, every time you copy a node in Blueprint, do remember that it's a text. Here you have it as a test, so it's very easy to share one. Okay, so I'll go to my Blueprint hookshot inside this function and paste everything. I'll connect it like this, and the result of this function, remember, it was a location. So I'll click on the function. Could be here, could also be here, the same. And I'll create an output. This output should be a location, so it will be a vector. And this is the end character location. That way, if I go here, at the end, it will be this location. Now, I do need to make certain that this location exists, that we have collided with something. Otherwise, well, this will be not the information that I might be needing. So I'll put an if branch here, and you can see that it already fixed some of the formatting for me. If I collided with something, this capsule collided with something, then it will be the end character location. Otherwise, I'll copy and paste this return node. If this is false, I will be using the trace start location. Or could be also the trace end, because it didn't collide with anything, which should be very weird actually, but let's just put it like that, trace end. Let's compile, and you will see that we have a lot of errors. First, we need this capsule component. And second, we do need the first person camera. This could be sent as inputs. So I'll be using the first person camera first. I'll just drag from this target and connect it here. Not connect it, but just drag it on top of the function, so you create the input pin. Right now, this is a scene component. It's fine. You could select here, like, no, it must be a camera component. Yeah, if you want to be really specific. And this will be the character camera. And we can delete that. We do need the capsule component. So again, we could just create here a new input instead of camera component, capsule component. Well, it's this one, capsule collision. capsule collision component. Object reference, and this will be the capsule collision. Now, right now, if I compile, it's still throwing me an error. We have this capsule collision. We need to replace this one. Whenever you have an input of a function, you can call it directly instead of just dragging and dropping the pin. For example, you can just right click and get capsule collision. And it's the same value. But we can drag it here. And we can, with Control and click, you just need to leave pressing the Control key and drag and drop this on top. And we can delete that. And now with that, if we compile and save, everything should be working the same. Let's go back to the first person character. I'll be as bold as I can and select everything except this set end character location. Everything at the middle, and just delete it. From the hookshot, I'll get calculate hookshot hit. And from here, I'll connect these two nodes, the set and the end character location. And now I should be getting the same functionality. If we save and compile, let's press play. If I click, whoops, I access none here. Oh, and it is telling me that this value had a non-value and this value also had a non-value. Because here in my calculate hookshot hit, I didn't connect the camera and I didn't connect the capsule collision. So let's not forget about that. First person camera and capsule collision is the capsule component collision. There we have it. Now let's play. Right click and I can see that it's colliding with something at the start. Now, what is happening here? Whenever we traced this, we were ignoring self. But right now, ignoring self is not the same as the self whenever I was doing it inside the character. So we are colliding with the collision of this character. We can add an actor to ignore to this line trace by dragging here, making a new array, and here I need to connect it to the character. We can get the camera, for example, or better yet, let's get the capsule collision that we already have here. Again, it's just get capsule collision. And I will ask for the owner of this component. And here it says follow the author chain to get the actual actor that owns this component. So let's press get owner, and this is the actor that I want to ignore. That way, whenever we press play, we can right click and we're not colliding with ourselves again. But we are able to use the same logic that we already have. Now here I'm jumping in place because I told it that whenever I didn't collide with anything, then I'm sending it the same actual value. So maybe I could also tell it if I actually collided with something or not, but we will be polishing a little bit more of this logic in a minute. One thing that I forgot to mention is that the main difference between functions and events are that the functions let us return an output value or values, but the events don't. So whenever a function gets executed, everything that is inside it will get run or executed in the same frame. And that's why we can get a result from it. Now, this means also that unlike an event, here inside a function, I can't use a delay node or a timeline, because these nodes affect with the time of execution. So that's why I choose a function here. Now, let's use the value that is being returned by this function in the first person character. With this, we have a new location that we want to move our character to. So I'll get the tick, and I don't know if there was a tick here. No, there wasn't. I'll create a tick event. Right click, tick. The tick event is an event that runs every tick. And by tick, Unreal Engine means frame. So every frame, this event is run. Event tick. And if you just create it normally, you won't get this parent. You can call that if you right click, add call to parent function, but it is not needed right now. So I'll just delete it. Okay, so this tick event gets run every frame. You can create a print string node if you want to make sure of that. You will see hello, hello, hello. But in my case, I want to translate the movement of my character to the new location. So here I'll create a set actor location. And here the target is self, which is fine, which is the first person character. And I need to select a new location. If I just put end character location, then whenever I press play, right now I'll be going to the 0, 0. So be very careful with that. And every tick I'm staying here even though I'm trying to move. If I change the end character location, then I'm moving there immediately. So I need to make a transition or an interpolation between the current location and this end character location. So what I'm going to do is, first, here in new location, I'm going to search for the interp from interpolation and interp to constant, because I want the movement to be constant. Otherwise, it will start slow and then get... this gives you, like it says, a smoother feeling. But in this case, I want it to be very, very constant. So this constant needs as an input the current value and the target value. I have the target value here, so I'll connect it. And character location is my target. And my current location is the actual actor location. So I have it like this. Now this delta time will let this interp node, how much of a movement it needs to add. So the delta time needs to go with the delta seconds. Now, if you don't really know what a delta second is, it's just the time needed, or well, the time between frames. So if you are rendering like 60 frames a second, and let's say that dot, and this is 60 frames a second, the delta time is the time between the time needed to render from one frame to the other one. Now, this delta seconds is not a constant value because if you have more stuff in screen, then it gets harder to render stuff. But if you were rendering at a slower pace, let's say like this, then you will need more time, or well, it means that you need more time to render frames. So this is the time that is being used by this interpolation. So whenever you reach this point of time, and oh boy, I cannot draw today. Whenever you reach this point of time, then you can add the same value regardless of the frames that you are running your game to. Although I need to say it's not perfect, but it's good enough. The interp speed is the speed of the interpolation, and it will be the speed of my character, of this movement. So if you just put 300. When I press play, right now it will try to interpolate to the 0, 0, which doesn't have a value, but I'll go here, and now I'm interpolating to that new value. And have in account that if you move around, you are running away from that interpolation. Now it needs to be a lot faster, so I'll just put 2000. Yeah, that feels good enough for me. Now, why am I sometimes shaking around violently? Because I have not tell it to stop. And because it's in the tick, if I press Shift F1 and move it around here and I select the first person character, I see that this is always running. So I need to know a way of only running this whenever we have a new location to go. So I do need to create a new state or some variable that can hold that value if I need to go somewhere. So what I'm going to do is create an if or branch. It's called branch. Very used to just calling it if. And here I need a condition. I will promote this to a variable, and this value, I'll rename it with F2. I'll rename it to go to destination. Now this code won't run, or I guess it will run because by default is in true. Let me change it to false and save it. Let's play again, and now it won't run even though I'm hitting the targets. Right? So I do need to make this work. So I'll just put here, whenever I'm calculating the hookshot hit, go to destination, let's set it. I'm just dragging it with Alt being hold. If you drag it around with and you hold Control is a get, Alt is a set. I'll set this to true. And now, whenever I have a new destination, I'm going there, but I also need to stop someplace, right? So I will, in the tick, I will add another branch node. And here, I need to compare the actual value of my character and compare it with this end location. So I'm going to copy and paste this. I will see if both of them are equal. And connect it to this branch. Now, if this is true, it means I already reached the destination, so I'll put this to false. Like this. So now if I press play, if I reach the destination, immediately I can move around, and now it's working correctly. Well, most of the times, but don't worry too much about it. We will fix it. We will polish this code. But if you are understanding what we are doing right now, then it's a very good sign. Okay, let's continue. An obvious error that we have is that whenever we don't shoot anything, we are still translating or moving around our character. So we can know very easily if we have hit something. Here in the calculate hookshot hit, here I know if I'm colliding with something. So if this is false, then what I should return is that I didn't collide with anything. I'll copy and paste one of these return nodes. And here, if this didn't collide with anything, I'll connect this. End character location will be 0, 0. And not only that, but I need to add a new output. This will be a boolean. And I will tell it if the hit was successful. And I'm going to drag and drop it on top of the end character location. Here the hit successful is false because this line trace didn't hit anything. And in these two cases, the hit was successful. Let's compile and save, and let's go back to the character. With this hit successful, I can press if, a branch, and now if the hit was successful, then I will for sure save the end character location, and let's put this character to go to the destination. Let's press play. If I don't hit anything, nothing happens. If I hit something, then for sure my character is working correctly. Now, this is where the tutorial gets a little bit more advanced. We're gonna tackle the graphic part of the hookshot. So we're going to replace this sphere for sure. For that, we will go to the bridge to get some Quixel assets. If you don't have the bridge open, you can go to content drawer, add Quixel content. This will open the bridge, and here I will search for hook. And I already found one. I believe it was this one. Wall-mounted metal hook. You download it, and I will export it in medium quality. It's more than enough. Now I do need a chain. Here I have a chain, but it's mounted in something that it's not something that I could use easily. So I'll search also for a chain. Now there is a modular chain here. There is this one here, and there is this one here. I liked this one. Modular chain, 1 meter, and chain links. 1 meter means that it's going to be easier to calculate. Okay, so let's import it, or well, export it from Bridge and into Unreal. And now we also have the chain. I'll make use of this. And if you go to the map and you drag and drop this last one, this is the chain that I will want to use. Not necessarily the links. I mean, we could create links, a lot of links, but it's too much trouble and it will be more or less the same, but it will be more effort and more resources spent on that in terms of processing power. So for now, using this chain, more than enough. Here in the test map, I'll delete it. Okay, so let's go to the hookshot. This sphere will be the, well, it can be the hook, let's call it hook. And I need another static mesh, which right now it was created under the hook. I don't need that, so I'll drag and drop it on top so they're at the same level. And this will be the first chain. Now let's replace the values. Here, this first chain, let's rescale it to the default values, which is 1. Select the chain, and here it is, modular chain 1. Oh, it was the links. The last one, I believe it's the one that I'm looking for. There it is. Like this. And the hook, again, the scale, you can put it back to 111. And the static mesh will be the hook. And because it was holding the sphere, right now it has this basic shape material. Just remove it, reset this property to the default value, and now we have the actual chain. Perfect. Now, how will this chain work? I'm going to do the logic in the construction script, just so you know how it will be working, right? Okay, so let's start. Here in the construction script, this variable, I never used it. It was just an example. I'll create another variable called the test end location. And I will put it as a vector. I will put it as instance editable and show 3D widget. This let me put the hookshot in the map. For example, like this. And I have this test end location. What I want to do with this test end location is that wherever this end location is, my hook should be there. So that's the first step on this part. Getting the hook to be in the proper location. So here in the blueprint hookshot, I can delete the other static mesh editors. Here in the hookshot, I will be using the set world location and rotation. So I have the hook here, set world location and rotation. So I'm setting this location and rotation in terms of the world and not the relative. Whenever I'm telling world location, I mean this actual location, which you can see here, which is 700 something. But the relative location of this hook right now is 0, 0, 0. 0, 0, 0. Here it is. So this changes it in the world, not inside it. Okay, so with this, the target is the hook. Perfect. The new location is the get actor location plus this test end location. Why? Because this test end location also gives me a value in relative coordinates. So 0, 0, 0, I need to add it to the actual world location of the actor. If I connect it like this construction script gets run every time a property is changed inside the blueprint. So it runs even before the begin play here. Which let us, here in the map, whenever we change a property, for example, the value of this vector, it also gets run that set world location. Now I need to set the rotation because I need it to look towards the correct direction, which would be this one. Right? So to get that rotation, Here we have new rotation, and we do need to get the direction between the starting point, which is the get actor location. Again, I will use get unit direction vector. And I do need this point. So I can just copy and paste them, or I could also connect it like this. I want to translate this into a rotation. And if I'm using a unit vector, I can just do it immediately. It will create for me this rotation from X vector, which is fine. Now, if I compile, I will test my blueprint, and I will see that my hook is actually rotating in the correct direction. So that's the first piece of the puzzle when working with this. The next piece of the puzzle is this chain, which is the first chain of the links. This first chain, and you will see why I'm calling it first chain, needs to also look toward the same direction of my hook. So just so I make a good difference, I'll just put a sequence node here. And after setting up the hook, which I can select everything here, press the C key, which is for comment. C for comment, makes sense. Call it hook location and rotation. I will get my first chain, and I will set the world rotation. Why am I not setting the location also? Because the location will always be in relative 0, which means that if my blueprint started here, I still want my first chain to be anchored here. So let's connect the same node here. And let's press play. Oh, excuse me, play now. No, it may crash. Oof. I thought it was going to crash. So let me save everything. It has already crashed 2 times. Okay, so now my chain, if I can click it, is looking towards the direction of my hook, of the test end location. But I want it for the change to get scaled. So when it's here, it's smaller, and when it's here, it's just the same. I do not want to upscale it because it will look terrible. For sure, it will look terrible. But I do want to make it a little bit smaller. So for that, we will do the following. Let's go back to the blueprint hookshot. And what we need to do is set, I'll copy and paste this first chain, set the relative scale. Because this, I really do not need the actual word scale, because the test end location is already in relative values. So let's connect it like this. How do I determine the new scale? Well, if I go to my viewport and I click on my chain, then I can scale it in X, I can scale it in Y, or I can scale it in Z. And as you see, the only value that I need is to scale it in X. So I'm going to do that. Scale in X. So I'm just going to right click, split struct pin, and in Y I'll put 1, and in Z I will put 1 also. I need to find this X value. To do that, I need to divide something. First, I need to know how long this chain is. And because I had the mesh here, I can know exactly how large it is. 103 unreal units. But if I use 103, then it will not connect with this other part. So it seems that 100 would be the perfect place to determine this actual scale, or well, size of the chain. So I do need to save this as a variable. Create a new variable. This one is a float. That's an integer. This one is a float, and I'll call it chain mesh length. Now I need to divide this by the distance between the starting point, which is the get actor location, and the actual point in the world of my end location, which is this one. I need to get the distance between these 2 points. So for example, get distance. And with this distance, I can get this scale. Right now, if I check this distance, I'll put a print node here. Print string. I'll connect this print string here. And I'll press play. Right now, if you didn't manage to see it, we can see it here. I will move it around. You're not seeing anything. Well, it's in the output log. And let's not worry about the 0 components scale set to 0. Here I'm seeing the distance. I will divide this distance by the actual chain mesh length. So this distance, but I want to know the remainder, whatever it remains from actually doing this operation, because if this is 100, I want to just do a scale 0. And you will see why I'm doing this. So for now, let's just do this division, whole and remainder. The divisor is this one, the chain mesh length. And the remainder, for example, if both of them were 100, this will be 1, because that's a whole number. And this will be 0, the remainder. If the dividend was 120, this still will be 1. And the remainder will be 20. Now, I only need this remainder. And you will see why I'm doing this whenever I add the next part of the graphic part. For now, we can just get this remainder. And now I have a value between 0 and 99.9. 99999. So with this, I can divide it by the chain mesh length. Oh, and I can delete the print string for now. And this is another cool feature of the plugin. You press Shift Delete and it leaves your wires intact. Okay, so here, the remainder, I'm dividing it by the chain mesh length. This will never be 1. It will be always a value between 0 and 0.99999. I'm just going to connect it with X and to compile it and save. If I go to the test map, whenever I get a value of near 100, then it gets scaled down. But whenever I'm closer, it should be scaling correctly. And let me go to the hookshot. Oh, and here I didn't put the actual value of the chain mesh length. I overlooked it. So let's put 100 there. And now let's go to the test map, and now it should be working correctly like this. And whenever I go to a value near 100, it gets returned. Now you will ask me, why? Ram, what are you doing? You could just scale it up and that will be it. But it will look terrible, especially if this end location was too long. What I want to do here is, and maybe you could have guessed it, I want to create the actual chain with the normal value that is 100. This will be 100, and I'm drawing with the mouse here. And create one again here, and one again here. The only chain that I want to scale is this one. Why? Because I cannot fake the actual chains. I mean, I could create a little chain for here, and a chain link here, a chain link here, but it's too much stuff. I can't be bothered. So I'm just scaling this part, and the other parts will be the actual full chain. So that's what we're going to do now, and we will make the effect work for us. Okay, so don't worry, we got this. We're professionals here, so we want a good result. Let's go back to the hookshot. And now we want to create as many meshes of the chain as we need. To do that, well, we could create another here, a static mesh, put it as a chain. Where is the chain? It's the last one, I believe. Here it is. And duplicate it and do that in the construction script. And now we have two chains, something like that. But if we create too many components, the engine will be very, very sad. Because creating a lot of components is not a good way of handling this type of logic, because creating a component is very costly. Creating stuff and destroying stuff inside the engine, in any engine, it's one of the most consuming operations for the CPU, right? So what we're going to do is click on the default scene root, add a new component, and this component is called instanced static mesh. This means that this static mesh gets loaded once. We will select the static mesh, which is the chains. It was the last one, this one. And you will see that nothing happened. I'm not seeing any chain. I'm not even seeing the first chain. And well, that's happening because the test location right now is 0, but if I move it here, it also gets run. So yeah, don't worry too much about it. I'll put it back to 0. But in the instance static mesh, right now I already loaded this static mesh. I only need to create instances of this one. So here I can go to the instances category, create a new one, and now I have it. I can create a new one, and well, the next one was created on top, but I could move it around. And we can have hundreds or thousands of instances, and well, I will not lie to you and tell you it will be just fine, but it will be a lot better than just created 100 or thousands of components, of static mesh components. I'll get rid of these instances, because what we just did right now is what I want to do here in the construction script. And it's not that hard to do. Let's see if I'm missing anything. Let's comment this. And this will be the first chain. Rotation and scale. Let's go to the sequence node. Let's create a new pin. And in this one, I want to know if this division had a return value of a whole number. Because if this is 0, well, I really don't want to create chains, because the first chain can't handle it. So let me copy and paste this. And I will do a branch. Here, I'll ask, where is it? Is my return value, which is the whole number, is greater than 0? If it is, then we're going to start doing some magic. What we want to do is set up the chains, that is instance chains. I'm going to call it instance chains, because this will be multiple chains. So I first need to set up the actual location. For now, here in the instance chains, I'm going to create one instance. Where is my instances? Just one. So we have something to work with. Here it is. So instance chains, I will set the world, location, and rotation. We need a new location. How can we calculate the new location? The rotation, pretty simple. And we like to start with simple, right? So we can just copy and paste this. It's the same operation that we have been doing a lot. Just paste it here. If you notice you are doing something like this a lot, you can convert it to a function, or you can convert it to a macro. Doesn't matter. It's a little more easier to understand later. But this is test code, because we will need to migrate this to the event graph in a moment. So I'm not worrying too much about that. We can clean up stuff later. Okay, so now with this, I have the rotation. If I'll save and compile, I have the rotation of the chain. Perfect. Oh, well, I do not have the rotation of the chain, because whenever I'm going more than 100, this chain is going to the 0, 0, which is here. I do need to get a good position to put this chain in, which it would be where the first chain ends here. So I need to get that. Let's go back to the hookshot and let me save this first person character. Hookshot. And to get this new location, which right now is in 0, 0, world location, I will need to get the actor location, which is this one. And I will also need to get that direction, which I have it here. Multiply it to the distance, which I have it here, of this is the length of the actual first chain. So yeah, this is what we need to do. Add, addition. This unit direction needs to be multiplied, so I'll just type here multiply. Connect it here. Multiply with the unit. Here needs to be a float. And it needs to be this one. And now that's my new location. So again, we had the direction. We needed that length or distance, which is this one, which is the length that the first chain has. And when we multiply this together, we add it to the getActor location so we can get the actual location of what we have here. So in the test map, I will have this. Whenever is less than 0, excuse me, than 100, which means that there is no whole number to be divided, this happens. But if it's more, then this happens. Which looks pretty nice, actually. Now, the problem will start whenever we go farther, because, well, the scale is going back to its normal place. And I here have 100 of distance where I can add a new chain. So we need to start adding chains dynamically. Let's go back to the hookshot. And after doing everything, and I will put this a little bit more downwards. After doing this, what I need to do is create instances as I see fit. How many instances do I need? Well, the number that I have here, which is the whole number of the division. If this was 100, 100 by 100 divided by 100, 100 divided by 100 means 1, which means that I need to create one chain. 2, which will mean that this is 200 and this is 100. And the intermediate values, it don't matter because I'm still getting the whole value here. So for this, I need to do something sometimes, some amount of times. That's what I wanted to say. So I'm going to use this for loop. And it's not the for each loop, it's the for loop. And this organized my notes. This for loop will need to be run X amount of times, and that amount of times is this amount of times. So I'm going to connect it to the last index. Just remember that when you're using a for loop, the first index is 0. And if it says that the last index is 0, this is running one time. If you have 1 here, this is running 2 times. The first one is the 0 times, and the second one is the 1 time. So, could be a little bit confusing at first, but whenever you know that, you can understand why here I'm going to subtract. Oh, and I didn't want to do that. Subtract like this. This should be left the same. But here, I'm going to subtract 1. And if it is making a mess, again, you can just copy and paste this. Don't even worry too much about it. Like this. Subtract by 1, so that way we are running the amount of times that we should be running it. And inside it, I need to get the instance chains. I need to add an instance. Connect this. And this new instance needs a transform. I'm only going to modify the actual location. So we can just make that transform. Here, it did it for me. It already arranged it for me. And we need this location. This location, very simple. It's just in the X value. So split. Here is the X value. And I'm going to get this index. And I'm going to multiply it by the chain length, well, of the mesh. And now I'm going to connect this like this. So if it's the first chain, this is in the 0 value because this index will be 0. If it's the second one, this will be 1. 1 times 100, it's 100. So that way we're controlling where do I want the chain to be spawned. Now I do need to click here in my instance chain and remove the chain that I already added. Where is it? Instances. Just remove the one that we added manually. Compile and save. And let's see if this is working. Every time that a new chain needs to be created, we create it. And it don't matter where the direction is. That really doesn't matter. So with this, if I had a first person view and I see that this is going far, you really don't notice, or you will see that you won't notice that stretching so much. But now we have the graphic part half solved. I know we have took like half an hour to make this part look like it is, but don't worry, things will start getting a little bit easier. Just a little bit easier. Now that we have this working, we need to convert it to a real-time logic, because this construction script runs only at the start, runs only whenever you change any parameter before the game starts. But we really want to use this when the game is in progress, so we need to change stuff. First, we can just select this and comment it like instance chains properties or settings. Yeah, it's a lot better. I'm in the construction script. Now, I don't really need this. So I'm going to disconnect it. And I know, it's like, oh, we spent half an hour in this. I'm disconnected, yes. But don't worry, we're gonna copy and paste most of the code. We will need to go to the event graph. And we will be using that tick. Why? Because the chain will be able to move around a little bit whenever it's going forward, whenever it's going towards us. So we do need to process this in the tick. It would be a lot better if we did it in C++, but it's not the end of the world if we do it in Blueprint. So the first thing that we do need to copy and paste is the hook code. So here in the hook, no, this is calculate hooks. This is the construction script. We have the hook location and rotation. So we need everything here. Copy it. Go to the event graph and paste it here. And I'll be using also the sequence that we had before. So here, sequence. I'll connect this to my hook. Perfect. And we need to do a little bit of changes here. And it's really, really simple. Which is the thing that I need to change is this test end location. I don't really want to set manually my test end location here. I want that end location, that true end location, that I'm going to call maybe target location. I want it to be wherever I clicked on. So if I press play, if I click here, then I want it to be there, in that point. Where can I get that? Well, in calculate hook. Calculate hookshot hit. Where is it? This last one, remember, is the end character location. But this first one is actually the end Oh, the hit of the hookshot. So now I want to save that, which is this impact point. So if I collided with something, I want that hookshot end location, and here in variables I'll just create a new one called target hookshot target location. Here it is. This is a vector because it's a location, and I want to put this here. And again, the plugin is very useful. Control Q while I'm hovering in the wire, and it adds it between this. And now I want this impact point to be saved here. Yeah, and that's that. We have the target hook shot location. Now, this target hook shot can also be a missed shot. So I should be able also to save it. Let's copy here and paste it. Oops. Paste it here. I want to add it here. And the location of the hook shot, even though it won't hit anything, I do need to put it at the trace end location. And that reminds me that here I had a value called just 200, 2000. This is the actual hookshot chain value. So I could create a variable for that. Yeah, it would be good to have here. Like, let's promote it to a variable. This will be the chain hookshot range, because this is the actual range of the hookshot, and it should be 2000. There it is. Perfect. Okay, so we have replaced this number with this value. Here, if we hit something, I put it as a hookshot as a target hookshot location. And if I don't hit anything, the trace end, which will be this end location, I'll save it as a target location. Pretty good. So compile, save it. And in the event graph, I'm going to change this. Instead of using the test end location, I will be using the target hookshot location. So I'm hovering here, pressing Control, holding Control, and moving the values to my target hookshot location. Now, if I save and I press play, if I had a value, for example, here, oh, come on, I click here, we will see that the actual hook is there. And well, it's rotating where am I? But I can see it there, which is fine. And if I hit nothing, then it's also there. So the hook is now working in terms of real-time position. Okay, next one is the where is it? It's the first chain. So let's copy this. And I believe you don't really need more explanation, but I'm doing exactly the same, right? So in this case, the rotation is the same as this one. And I do need to connect it here. And then I need to modify this scale, because just look for anything that says test end location. And I just need to, well, delete it and put the target hook location instead. Oh, and it really make a little bit of a mess. There it is. We replace with the target hookshot location, and everything should stay the same. Perfect. So now the first mesh, let's compile and save, should be working correctly. Let's save this. Now I see that my mesh is being scaled correctly. Now I just need to add my instances. So again, copy and paste everything here. And this is the part where could change a bit from what we already have. The first part, not so much. But instead of having this check, we really won't need it. We always want to run it because we want every frame to be updated with the number of chains that we should have. So we will connect the set word location, and we can delete this, I believe. Let me just move it to another place. Yeah. We will connect this set word location and rotation to the another sequence node that I didn't create. So again, I'll connect it here. Perfect. Now, we do have this reminder that is helping us here. Here we have a test end location. This needs to change. So I'll just delete it and I'll put my target hook location. Again, I have this test end location. This should not be. And replace it by the target location. Okay, so far, so good. We will have the correct location and rotation, but we need to add instances or remove them. So it's an extra layer of complexity. Because in the construction script, whenever it gets run, it removed automatically the older ones. But in our case, we do need to remove them when we don't need them and add them when we need them. So here is where the actual checking comes. Let me just push everything to the side, and I'll also remove this comment box. I can copy and paste it later. And first, I'll create an if, and this will organize my nodes a little bit. Okay, there it is. Just know that it's the same. Here, I have this branch node. I need to know when do I have more space than the actual instances that I have. So again, we do need, I can delete this. And I can delete this. We need this value again. Let me copy it and let me paste it. I need this return number. If it's 0, I don't need anything. If it's more than 0, then I need to create more instances. So I need to check it against the number of instances that actually exist now. So here I'll just get instance count. There it is. Get instance count. If we don't have anything, this is 0, 1, 1. Perfect. So I just need to check if this number, this whole value, is greater than the actual instance count. So if I need 1 and I do not have 1 instance, then I want to create more. So let's connect this here to that branch. And if this is true, I need to create more. So here in the for loop, I need the amount of instances to be the same value of my return number, which is this one, the return value, which is, yeah, it's this one, exactly like that. I already have it here, so I'm just going to connect it like this. It's the same. And I don't want to fix again this test end location, so that's why I'm doing it like that. And we will just leave it at that. We will see the error that happens. Now, for loop, I want to add the instance. This is okay. This is okay. And this is also okay. Let's compile, save, and let's press play. Hopefully it doesn't crash. Now, I'm seeing the instances that I need. I'm not destroying them, so that's why here I get more instances. And they're colliding, they're going towards the ground, so I can't see them all, but we know that we are not destroying correctly all of our instances. Now, what's the error? Right now, I'm creating duplicate instances. And I don't know if I'm going to be able to see them because they are in the same exact spot. Because we are always telling it to start at the first index 0. And if this index already existed, I'm creating one on top of the index, on top of the chain that already existed. This means that eventually I could create too many instances, and when I try to delete them, then it won't work correctly. So to fix this, I need to start at the last index that I have, which is this one. So if I already had 2 instances, I will start at 2 and then create as many as I needed here. So with that said, let's just press save and compile and play, and you will see that it's exactly the same. Yeah, it's the same, but still, now it should be working correctly. And now we are not getting instances, well, more instances that we need. We just need now to remove instances. And I can press F with my super plugin, so this gets organized more cleanly, like this. So you can see it in a more easier manner. Now, we have this to check if we need to add. So let's just put a comment here. Add more instances. Now I need to take in account the other case, which is when I need to remove values. How can I check this? Well, it's almost the same. We have this here, and we will get if we have less values than our instance count. If we have less values that we need than what our instance count has, then we need to delete instance counts. So this is the other value, well, the other case. Yeah, and that's a little bit better, I believe. I could just duplicate this so it's better organized. Oh, whoops. I did not need the reminder. I need this one and this one. Now should be more easier and with more space. Okay, so here I'm adding more instances. Here I want less instances. Again, we will need to determine how many instances we need to remove. So again, we need a for loop. This one. The first index will be the actual number here. First index. And the last index will be the current count minus 1. Oh, and this is not what I wanted. Control C. Control C. I'll just put here subtract. No. That's substring. Subtract. Oh, I can't. Right click on anything. Subtract. This is just minus. Ah, there it is. Subtract. Okay. My bad. Connect it to the last index and connect it to the instance count. This is minus 1. You already know it. And I already explained it. Just remember that the index usually starts at 0, so that's why minus 1. Okay, that's pretty much it. Now we just need to remove those indexes. These are the indices that are on top of the number that we need, that are greater than the number that we need. So that's why we are starting at this number, first index, and the index count, to remove the values that, well, I don't really need anymore. Get instance chained, get remove instances. Well, could be instances, just remove instance. We will have a lot more control with this. Remove instance, and we just need to pass the index. And that's it. Let's compile, let's save, test map, let's play. And whenever I click here, which was a good value, come on, this one, you will see that I no longer have a chain that stretches infinitely. Now I'm adding chains, and I'm also removing them. And as you can see, you don't really notice the fact that the first one is stretching. And don't worry about that. It will get corrected. Don't worry. So pretty cool, right? We now have a way of telling our instances whenever we want them to be created or whenever we want them to be removed. Yep. Let's continue. The next step of the hookshot is to actually make it move. This will be done when we click. We should get the actual animation of the hookshot going to the place. Alright, so let's do that. I'll go to the hookshot, and this part of the code is good. I promised that I was going to, well, let me press F to format it and C to paste this comment. F2, Control C, and in the event graph, F2 and Control V. Right. This logic handles the actual movement of the chain. I'm just giving it a place to be, and easier said than done. It is calculating where do the hook needs to be, where do the chain needs to be, and where do the chains, the instance chains, needs to be, or if they need to be created. But I need to handle a movement. Now we will create a variable that will hold that specific movement, that will be holding the current movement, so we can later on do something very similar, like with what we did with the character. We have an set actor location and we are interpolating stuff. But the value that we need to interpolate is this actual target hook location. Now, we don't always want our hookshot to first to work, and second to go towards the point, the target point, because sometimes it needs to go here, but sometimes it needs to return. So we need to save these states inside the hookshot. I'm going to create an enumerator to define those states. So right click, blueprints, enumeration, and this will be E from enumerator, hookshot states, or states. There are multiple states. For now, I need, usually it's a good practice for the first one to be just none. The second one will be idle, when the hookshot is not doing anything, and we should not track the movement of the hookshot. The next one will be going, because it's moving toward the goal. And the next one will be returning, whenever the hookshot needs to return to its position because it didn't hit anything, and then it needs to return. If we need it, what am I saying? If we need more of these states, we can open this file and then we can add it. And we will probably do, if I remember correctly. Because I already done this, but I really don't like to create all the states, because you don't really get the experience of, oh, this is why I need to do this. That's also why I do not like to create a lot of variables at the start. It's like, oh, I know the way, but I want you to discover it with me at the same time. For now, these were the states, the normal states that I came up right now. An idle state, a state where the hookshot is going to the location, and the other when it returns. Now, when it is idle, I really do not want to run any of this code. This code that I'm going to call it handle hookshot locations. I'm going to move it a little bit, and here I'm going to add an if value. And if the hookshot is in an idle state, I don't want to run any of this. Now I need to set up my state here, so I'll create a variable. This will be called hookshot state. Could also be just state. Let's just call it this, hookshot state, and this will be hookshot states. Compile. By default will be none. And I will be creating this one, compare, equal, and it should be not equal, because not equal. Oh, and I need to click on the not equal enum, like this, and connect it here. Now, if it is not the idle, then for sure run it. But if it is, then it won't run. So far, so good. I need to check now the actual state to change it. Whenever this blueprint is created, I want it to be idle. I could also set up the idle here, just like this. So for now, I'm going to do it like that. Okay, so now it is in idle. Doesn't matter what happens. It is not moving to any place. Perfect. Now, whenever I click on something that I can go towards, I don't want to go towards it immediately. I want to first let that hookshot get there and then go towards it. So here in the first person character, for now, I'm going to disable this. This go to destination. So now, doesn't matter what I click, nothing happens. Perfect. For now, so far, so good. Now the first thing that I need to check is the fact that I'm going towards a place. And here in the hookshot, I have the state of going towards a place. Where can I know that I'm going towards a place? Well, in the calculate hookshot function. Because if I manage to hit something like this, then for sure I should be going somewhere. Now, let's change the value. And this will be going, and this also will be going on top. Come on. Work with me, editor. There it is. And I need to connect it here. Now, the thing that should happen whenever we're going, whenever the hookshot is going somewhere, it's a good practice to clean stuff. For example, to clean if there were already instances here, for sure clean them. And also we should set up the current location as the start, just in case we need them. And because for sure if we're starting to go someplace, then it makes sense that the current location of my hookshot is at the start of the hookshot. So because changing the state of the hookshot will mean a larger change in other values, then what I'm going to do is create another function called handle set grappling, set hookshot state. What I'm going to put here is a set node, connect it like this. So this function is receiving this hookshot state, and I will call it new hookshot state. And now when I do anything with this, I'm going to create a switch. And a switch, whenever you're working with enumerators, will let us take decisions depending on the current state of the enumerator, which is actually holding just a value between 0 and 255. But we can give them a name. For example, 0 is none, 1 is idle, 2 is going, and so on. So when we are going to a place, what I will be wanting to do is take my instance chains. Oh, I double click them. Take the instance chains and clear all the instances that already exist there. Not only that, I want to do something with the locations. But for now, let's just clear the instance. Let's go to the event graph. And now, this is controlling the hookshot locations, but is not actually changing the value of the target, right? For that, we need to do something else. And for that, I'm going to get my hookshot state, copy it here, again do a switch, and I'm going to create a sequence here. Sequence, because first I want to change the value of where the hook should go, and then I want to update it here. Right, so when we are going, which we are changing in my calculate hookshot hit. Oh, we're not changing it yet. Let's change it. Let's drag and drop the handle set hookshot state. And let's change it to going. And the same for here. I'm pasting it. Oh, not this one. This one. Pasting it here and adding it here. Going. It's fine. Going. This gets run. And now in the tick, we can enter this in the next frame. And when we are going towards something, I want to have a location of the current hook. We have a target location, right? Which could be, if this is the hookshot, the target location is this one, and the start location is this one. I want an animation so the hookshot can travel toward the target. So that's the new value that I need to determine. Is the same exact thing that we did here. But in this case, what we are going to want to change is the current location. And I will save it as a variable. Let's save current hook location. This is a vector. And I want to set it up here. Whenever we're going somewhere, this current hookshot location, I'm going to interpolate, and again, interp constant. I want to interpolate with the current location and the target, well, is the target location. Okay, here it is, target hook location. Now this delta time is this delta time. This interp speed, we will create a new variable called chain speed. And this chain speed, what could be a good value for the chain speed? Let's just put it, well, let's compile and set it up to 2500. Yeah, like that. Like that could be nice, could be nice. Now this is changing a current hook location, but we have not initialized this location. We will go to handle set hook shot state, and after clearing all the instances, what I'm going to do is initialize this. Where is my current hook location? It should be at the actual point of my hookshot. So get actor location. And I'll connect it like this. Now we have initialized it, and after going to, well, going, in the next frame, here in the tick, I will check, oh, you're going somewhere. I'll be sure to just interpolate the value. And I'm setting it up in the current hook location. I'm going to save it, I'm going to press play, and you will see that nothing happens. Why? Because here, where I'm handling the actual hookshot locations, I'm using the target instead of the current one. So I just need to replace this. Again, I see target here. Let's replace it. Target, replace it. This is done. Then the next part, target will be the current. Here I have another target one, current. And I believe that's it. Nope, I was missing this one. Yeah, and I replaced all the targets with current hook location. If I press play now, whenever I shot at something, I will see that it's going towards it. Pretty cool, right? Now, whenever we reach the destination, we should trigger the actual movement of the character, which is this one. So, in the hookshot, I need to determine that. Here in going, I want to do the same check I'm doing here. Like this. Branch. And if, where is it? My current location is equal to my target location. Let's just copy this. Equal. Get it here. Connect it here. Then I want to use my hookshot. So I do not have a state of the hookshot being used. So let me create one. In my enumerator, add a new enumerator, call it in use. And I'm going to move it on top of the returning one. The returning one is if I miss the shot and then I'm returning, which we should also add now that I think about it. So now here I can, and I do need to compile, I can handle set hookshot state and put a in use. But I do need to know if the place I'm going to, well, if I can use it, because here it reached the destination, but it has changed the value to in use, but this should be return. So I need to add another if node. And here I need to know if we missed the shot or not. Where do I have that information? In the calculate hook shot hit. Here I have if the hit was successful. And I might as well add another variable for this. Promote it to a variable. It's successful. And I do need to set it up here. Set. Put it here. And here the hit successful is false, which is fine. But here, after setting it up, after setting up the going state, the hit successful should be true because I did hit something. And at the end, I will put in hit successful, I'll just connect it like this and connect it like this. Perfect. Now with this information, I can save. I can go to my event graph and connect here if the hit was successful. If it is successful, then in use is fine. If it is not, here I'll type handle set hookshot state, and I'll put this to returning because I need this to return. Yep. And that's basically it, I believe. I'm changing the values correctly, but right now I'm not doing anything whenever I'm using the actual hookshot. So that's the next part, and this is the part where we see a little bit of blueprint communication. The hookshot needs to report to my first person character whenever the state has changed. And whenever the state is in use, here in the first person character, I want to run this logic. To do that, we need to create an event dispatcher. An event dispatcher, you can find it here. We can create it very simply, very easily, by just clicking here. And usually it has a name that reflects what's happening. For example, on hookshot state changed. And it's a way that this blueprint has to notify that something has happened. So let me go inside the handle set hookshot state. And I want this on hookshot state change every time we set the hookshot. And we are always using this function, so I can put the on hookshot state change, call it, and connect it here. Now, this event dispatcher, I need an input value, and I'll compile, and I need an input value here, input, that is also a hookshot state. Hookshot state, this will be called hookshot state. And now, compile, save. You will see that we have this node with an input node. I'll connect it here. And I'll connect the hookshot state to this new event dispatcher. This event dispatcher, it's telling whatever blueprint that is listening to this blueprint, to this hookshot blueprint, that the state has changed. If no one is listening to this blueprint, then nothing will be triggered. But we are going to make our first person character listen to this. So we will go to the first person character. We will go to the begin play. And if there isn't one, I'm going to create one. Here. And again, you can delete the parent node. If you had another parent that is in the character class, then for sure you will want to call the parent function of whatever you have this here. Okay, so in the character, begin blueprint. Here, I need to start listening to that event inside the hookshot. We need a reference, and luckily for us, the reference is inside the hookshot child actor component. From here, I'll get the child actor, and from here, I'll just cast it to the blueprint hookshot. I'll connect it, and now I need to do the actual listening. This, in Unreal, is called binding. So I can bind, and there are a lot of events, well, damage events, and the ones that we already create. Bind event to on hookshot state change. You will see binding, and you will also see assign. If you just type, for example, on hookshot, we have Assign, bind, call. Calling, we did that here in the blueprint. And unbinding if we want to stop listening to this event. In this case, we always want to listen to this event, so I'm not going to bother too much with the unbinding. Assign is the same as binding, but it already creates an... Oh, oops, what's happening there? It already creates an event for me. I could do the same if I just type bind, and here I put create event, and here create a matching function or event. I'm going to type event. I'm going to give it a name. Let's say this is on Hookshot state changed event. And I'll select it again. Nice. So this will be triggered now that I'm binding it at the start of the game. This will be triggered every time here in the hookshot this code is run, because this is notifying anyone that is binded to this event. That's why it's called an event dispatcher. It's dispatching the fact that it has been called. Now, what do I want to do whenever the state changes? Well, I first need to know which state we are in. So let's switch. And now I can, whenever it's in use, I'll change this value, this go to destination, and not going, in use, and I put it true. If I put this to true, in the tick, this will be true, and I can move towards the end character location. Perfect. So compile, save, play. Here, I didn't go to is using or is in use. I went to return, which I haven't made the logic for it yet. But here, oh, I didn't click it there. I did went to return, excuse me, to is in use, and that's why the logic did trigger. Pretty nice, right? Now, whenever we are successful, we do want to let the hookshot know, so we should change the state to a successful use state, which I don't believe we have. Here in the hookshot states, yeah, we don't have a successful one. So let's just create one, a new one. Success state, or successful use. And I'm going to put this on top of the returning, because the returning one is where the hookshot returns by itself to my position. Successful use, perfect. Save it, go to the hookshot, compile it and save it, and go to the first person character. And here in the tick, we had the logic, so we can stop going to a destination, right? So here, not only do I want to stop, but also what I want to do is set up, and I will copy and paste this part. I'll get the hookshot and I'll change it to handle set hookshot state. I'll put it to successful use. Now, why am I removing this node? Because every time this enters in a successful node, this here will also be triggered because I'm changing the state. So here I can open my other states, and whenever we are successful, we can tell it to just stop going to a destination. Pretty nice. Now, when we are successful, we have told the hookshot that we are successful, but we are not we have not told it yet what should we need to do when we are successful. But for now, let's just press play. Here I'm going to return in, here also returning, they're successful, and then I have it. In the first person, whenever I am successful, I should also tell my blueprint to go, and where is it? Yeah, to handle its state and go back to idle. So here in Hookshot, if we are successful, I'll tell it to handle, set handle hookshot state, and go back to idle. Compile, save, play. Oh, there we are not successful, but here we are. And we have a basic functionality now. Whenever I'm in idle, I should reset my hookshot. So yeah, we should do that. Yeah, and I'm in the right place to do that actually. Because here in idle, I can clear the instances again. I can set up the first chain, set is scale relative scale to 0, everything 0, or just X. It will be the same if X is. One of them is 0, you won't be able to see it. And the hook location, I should reset its relative location. So set relative location and rotation, and everything in 0, 0. Just like this. So I'll save and compile and play. Whenever I'm successful like this, then my hookshot returns to the normal value. If I'm not successful, then I'm not going back to idle. So well, we have this little issue. Also, whenever we start the game, I notice that I have this, like this. We should go to the idle again so we can start correctly. Let's go to the event graph. Let's search for the begin play if I have one. Here it is. And otherwise, you can right click and create it. And handle this, set it to idle, and play. And now it starts in this correct location. So good. We are almost done. Almost done. Now let's tell the chain to return to us whenever we don't hit anything. So again, here we had the going. Now we will use the returning. The returning is very similar, and I'm going to comment this code. I'm going to deselect these parts, put it here, and create a comment box. Call it going state. Now for the returning state, I again will want to use this interpolation. But the values are a little bit different. Oh, man. This interp constant that I'm going to put here, it will be later be formatted, so I'm not gonna worry too much. Delta time is the same one, but here is the difference. Current location is fine. But because we are returning to the starting point, we want the target to be the actor location, which is the starting point. The interrupt speed, I want it to be a little bit faster. So I'm just going to multiply this by 3. So it will be 3 times the normal chain speed because I want it to return faster. Yeah. Now with this, it will return. Compile, save it, play it. I don't hit anything and it returns to me. And it returns 3 times the speed. Maybe it's a little bit much. Maybe 2.5. Oh, whoops, 2.5 could be nice. Great. But we do need to put it in idle. Whenever it returns, here it's not in idle because I can see the chain actually being smashed there. So the same way that we did this part, it's the same way that we are going to be completing. And here, whenever this is true, I'm going to handle set hookshot state, and here go back to idle. Now I know I will be going to idle because whenever I press play and I go back to idle, this is being reset. Oh, and it didn't reset. What? Oh, and it's not resetted because here I'm comparing it with the target, but here I'm sending it to the actor location. So this should be the actor location. My bad completely. Now it should be being reset. Let's press play. And now it's reset because I'm not seeing the chain. And if I missed, then here I have it. Right. And again, I'm going to create a little comment box for this. I don't want to select the other comment box. And I'm going to put this a little bit upwards. Comment box. This is the returning state. And I'll press F so I will see what happens with this. All right. We are technically already done. Oh, the only things that we need to do now is polish the actual hookshot. There will be a lot of edge cases, but I will let you know of the most common ones. For example, let's say that you have a bigger object behind this. You will press play. You will click towards the bigger object, and that happens. If you're going to go through it either way, might as well disable the collision in your character. Not only that, but also make it so your character enters a new state of movement. So that's what we're going to do now. We're going to polish what we already have. We're going to make it so the character won't be too bothered about this. And let me remove the basic shape materials, otherwise I'm going to constantly be missing it. Right. That case I want to fix. And fixing that case will also fix this one. this one. Why? Because I will be removing the collision. Here in the first person character, whenever we enter to going somewhere, we don't really need to modify it to for now. Yeah, for now, no. Yeah, I was getting ahead of myself. We first will get the capsule component and we'll set it up as set collision enabled. And this will be no collision. Now, the next thing that I want to do is press play. And you will see that this problem never happens. Why? Because I no longer have collision. But this also means that if I try to move because I don't have collision, I can't use anything in my character movement component. So whenever we are successful, we do need to give the collision back. So here, enable collision. Collision enable. So far, so good. Let's press play. We move here. We do not no longer experience that issue because now we are going through the actual map, but then when we position ourselves, then the engine puts us in a correct position. And this gets rid of this annoying problem. And whenever you're in a first person view, you really don't care too much about your legs. Yeah, now it works correctly. Great, it's feeling a lot better. But we can make it feel even better. Why? Well, because the thing about this is that we could already write a advanced type of behavior. For example, when this is upwards, something like this. We can press here, go here, here, but you will see this. That means that our gravity won, our forces were bigger than this movement that we were adding. So whenever we are going to be successful, or we are going someplace else, I want to change the movement mode so we don't have gravity. So I'm going to get the character movement. I'll change it to set movement mode and change this to custom. We could use flying, but maybe later on you add flying in your game and then this means that there are duplicate. Let's just put it at custom. A custom mode, and I'm not going to revert it here. Here I should put walking and connect it. But a custom mode will mean that, well, if you are going there, well, there, you're in a custom mode. In this custom mode, you do not have gravity. You cannot move. You cannot do anything. You could do stuff if you decide that in that custom mode, inside C++, you're adding extra forces. But for Blueprint, custom mode is just to block everything, every input, etc. Let's connect it back to walking. And now, here, And it doesn't matter the forces that are applying the gravity, I will always be able to go to the hookshot. Pretty cool, right? Now, what I wanted to do is create a little hut so I can see where I'm shooting for. So let's do that now. Let's create a hut so I could get rid of the line trace that I'm using. I don't really need the hookshot states anymore. I don't think I need more states than what I already have. And in the framework, I'll create a new class. This class will be the hut class. This class will be in charge of managing everything that has to do with the hut. So I'm going to call it blueprint hut. I do need to set it up also in the game mode, so it starts being used. In the game mode, hut class, blueprint hut. Compile, save, and we're done with that. Let's open the hut class. This hut class will create the actual hut, but I do need to build the hut. So here in the mechanic hookshot folder, let's call user interface, and let's create a folder for that. UI, blueprint class, nope, excuse me, right click user interface, widget blueprint, common widget, and let's call it widget blueprint hut. A widget blueprint is a blueprint that lets me create user interfaces. And anything that comes inside it is a widget. And the final result, which is this hut, is also a widget. You can put widget inside widgets. And here I will go to the panel, go to canvas panel and drag one. That way I can put more than one widget here because some widgets only receive one child or one slot. This one can have many widgets inside it. But I only need an image. Here's an image. I'm going to anchor it correctly to the middle. Otherwise, if my screen resizes, you can see that the image is moving in relation to this anchor. But if I anchor it to the center, I also position it 0 in X and 0 in Y. Size could be 100 by 100 maybe. And alignment will be 0.5. 0.5. You can see what this is doing with the image. Now, when I scale this, it will always be in the middle of the screen, which is exactly what I need. I need an image for this. What I did was go to the internet and search for one. Whenever I did software in university, I used this page called Icon Finder. You can put here crosshair. And be sure that it's free. And be sure that the licenses, if you want to, for it to be for commercial use, you can put it here. Or if you don't want to tell who did the image, you can put no link back. And I will use this one. I'll download it. And here I have it. I already downloaded it before, but I'm going to open it and put it in a folder. And here I have it. I'm just going to call it crosshair. And I'm going to import it inside Unreal. Two ways to do that. You can just drag and drop it to the content browser, or you can also come here. Let's just import it here. Or it could be in the hookshot. UI is fine. Import. I'll search it. It was in my desktop assets. Crosshair. and here it is. Now I will be using this image here in the brush, and I'm going to select the crosshair that should be here. And it's a black crosshair. If I just compile and save it, I'll just press play and it's not there. But it's not there because my HUD has not tell Unreal to spawn this user interface, this widget. So let's go back to the Blueprint HUD, and in the begin play, I'm going to create a widget, select the class, which is the widget HUD, and here I'm going to add it to the viewport. Compile and save. If you later on want to hide this HUD or need access to it, you can create a variable and call it Blueprint HUD. I just do this by memory because usually you do need access to the HUD so you can update some values. So this is a way to have access to it after you create it. Okay, so now I press play and I should have this crosshair, this black crosshair, and let's see if it's working. And it is working. Yeah, because it does go at the center. Maybe right now is a little bit too big. And now I can tell that it is going to where I'm clicking. Right. Now, where exactly, or how could I change the color? For example, I want this to be red. Here in the image, we can change that tint. But if we change it to, for example, red, you will see that nothing is happening. Why not? Because the base image is white. Because it's white, and I'm going to cancel, we are multiplying a 0 value by the red color. And that's not going to work. We need this to be white. So I'm going to open the texture. Here in texture group, I'm going to set it up as UI because I'm only going to use it as UI. So this will get rid of any mipmap. I don't want mipmaps in my UI textures. I want them full resolution. And here in adjustments, in the RGB curve, I'm going to put -1. This will make it white because I'm inverting the colors. I'm inverting the values. Black was 0, inverted is 1. I'll save it. And now in my HUD, we have this white, which means that I can change the tint on it. And now is red. Now we have a reticle that could be any color really. But with this, I have a very good idea where I'm hitting stuff. If you think that it's not very precise, then we can do some more testing with it. And I'm feeling it like it's not that precise, but it should be. Maybe oh, you know what? Let's check where we're doing the trace. Should be in the hookshot, should be in calculate hookshot hit. And this is the trace. Oh, right. Here is the issue. We are using the direction of this character camera, but we are not using its location, so the location may vary a little bit. I'm going to get the world location of this component, of this camera component. Get world location. And I'm going to replace this get actor location. Like this. So I'm getting the world location of the camera and the direction of the camera. Let's see if that solves our issue. And now the trace should be exactly on the point. And it is. Yeah. Yeah, it was that little issue. And now it's very, very precise. Nice. So now we can get rid of this draw debug. Let's put it to none. And let's save everything. Save all. Well, we're almost 3 hours in, so I might as well polish it a little bit more. This is part of the secret sauce that I was talking at the start. We're going to make it feel a lot faster than what it actually is. We're going to play around with the FOV, with the field of view of my camera. And again, we want to keep this code very modular, which means that here in my first person character, I shouldn't be dealing too much with this type of stuff. But just for clarity's sake, I have left this part here. I could move it inside my hook shot and put everything there, but I'm leaving it here because it's kind of organized, okay? And you already know how to move stuff around. I don't want to do it again. I will waste your precious time by only organizing stuff. Okay, so what is the secret sauce? FOV. FOV here in the first person camera right now is at 90. If we bump it up and we press play, we'll see that the field of view has been increased. Now this makes that objects at my sides are moving faster. Or at least it will feel like it is moving faster. So we're going to play with that. Because the hookshot knows exactly when it's working, we're going to add it in the hookshot. We will go to the blueprint hookshot and we can get rid of the crosshair and the hat and the other hat, the widget hat and the blueprint hat. And whenever we're going somewhere, where is my event graph? Whenever we're going somewhere, we're gonna bump the FOV. And this is going like the chain is going, but it's actually when we are using the chain, the hookshot, here we're gonna bump up the FOV. So yeah, I misspoke. I want to set the field of view of the camera. I know that the node exists. You just need to put set field of view, but you won't find it here. If you remove the context sensitive check, you will find it here. Set field of view. And the target is a camera component, which I do need this for this set of field of view to work. Otherwise, if I just connect it like this and I press compile, I'll have an error. And this error won't let me compile and the game won't work. So where can I get this? I know that the hookshot is inside the character. And in the character, there is a first person camera. So I'm gonna let you know of another way you can get information that are inside actors that contain other actors, like the first person character that is contained in the hookshot. So I'll get the default scene root, which is this one. I'll ask for its attached parent. And let's use get attach parent. Here it is, get attached parent. This is giving me the scene component that is currently the parent of this default scene root. This default scene root is the root of this whole blueprint. So the parent of this one, in terms of attachment, is the capsule component. Because here, well, this child actor component is the actual parent. And from this parent, I will get the owner. which is the actual blueprint. And it's not this one, not the owner used primarily for network replication. It's the components get owner. Follow the outer chain to get the actor that owns this component, like this. Now, this will return the blueprint first person character. This returned the component, the capsule component, and this returns the actor. So now here I will ask for a camera component. I could cast it to the first person character. And from here I could get the camera. Come on, get first person camera and be done with it. But I already have shown you how to do this. Another way that you could get a camera without casting is by getting a component by class. This will return the first camera. If there are more cameras and you want to change them all, use get components by class. Here I'll put camera component. And finally, I will connect this to the field of view. And I will put this to 120. Yeah, 120 should be fine. If I compile, now it lets me. I'll press play. And whenever we are going somewhere, the field of view changes. Now I need to return it to its normal position. So whenever it is idle, I will want to return this value to normal. Okay, so how do I know which value is the default value? It would be a good idea to save it at the start. So here at the begin play, I'll get the same value, get the field of view, and I will save it to a variable called default. Come on. Default field of view. Connected, and I'm going to format it, and there it is. We have a default field of view. We need to set the default field of view. So whenever we are in idle, I want to set the field of view. So here in idle, I'll do the same thing. Copy it here. Idle. And here I will put the default field of view. Now we have it here. I'll press play. If I'm going, the field of view changes and then it returns to normal. And again, it's a lot. I was gonna say it's a bit rough around the edges, but really it's a lot rough. So what we can do, and let's ignore this for a second. What we can do is we can just interpolate. So here, interp, and put the context sensitive back. Interp to the default field of view will be the target. And the current one is, well, camera component get field of view. Put it here. Delta times speed. Well, delta time is this one. And the interp speed, I'll put it here 10. And I will put the same code in the other setup of the field of view. And I'm going to create this variable. No, I reset it. No, I reset it. Okay, that doesn't matter. I wanted to create a variable called target field of view. So now we have a default, we have a target. It's the same logic that we have been using for almost everything. The difference is that here I'm going to interpolate only floats and not vectors. This target will be the target, and the current will be, well, from this component, get current. Get field of view. Here it is. Put this here. Delta time again is this delta seconds. And the interp speed whenever you are going to the target one will be a little bit slower. So we want to go to the maximum field of view slower and return to the normal one very fast. I'm going to select these nodes, move it here, and this is the idle state. And let's see if it's working. Click here. Whoa. We are going to a 0 field of view because it seems that I forgot to set up. And again, let's not worry about too much of those errors. We will fix it in a minute. I have not set up this target field of view. Let me put it to 120. And now let's see how it works. Oh, that's very nice. Super nice. Super nice. And this kind of logics will work everywhere. For example, if I change the map to the map that comes with the first person, let's save everything. And let's change the game mode. Here is overriding the game mode. Just put clear. Game mode class, none. Now there's no overrides, so if I press play, I immediately will be using my normal. Yeah, it's working just fine. Here I didn't collide with that for some reason. But it is working properly. And because we're still polishing, let's put the actual hookshot in the hand of my character. I will click on the first person mesh. I will click on the skeletal arms. I will click here in the skeleton, and I can close the skeletal mesh. And here in the skeleton of the skeletal mesh, I'm going to preview an animation, which is the idle one. Here we have an idle animation. I'm going to press pause. And I'm going to create a socket in my character. I want a socket. I can see the bones. And I want this one, which is the hand, left hand. I'll right click it. I'll add socket. Now I have this hand socket. I'll move it around a little bit towards the place I should have. And this is not an exact science, so just for now, eyeball it as best as you can. Yeah, let's say there. Let's say that that's a good place. Save it and rename it like, let's put hookshot socket. Save it. Go back to the blueprint first person character and now select the hookshot child actor. You will need to move this inside the first person mesh. Like this. Now the hookshot is attached to the first person mesh. And this means that here in the hookshot, I can parent the socket to hookshot socket. Now it has moved around somewhere, so we do need to reset the location and the rotation. And we can see how it's ending up as. I see that the rotation is wrong, so I do need to modify that. Let's come here, and I will move my window so I have a little bit more space to check it with the actual result. So I can see if it is working correctly. In character, I will select it only. I only want to look at this socket. And now if I move it here a little bit, could be a lot better. Maybe here could be fine. Now I need to rotate it. I'll press E and start rotating. That could be fine. If you want to know the values of the socket, here they are. Sometimes setting them directly have given me other results, so that's why I didn't want to do it like that. You just need to eyeball it a little bit. So now if I press Alt P to play the game, I can see my hookshot wherever my hand is. And if I'm moving around, I can still see it. Now I can close this. The last thing, the super last thing that I wanted to add is show you ways that you can polish the behavior even more. And this will really depend on the type of game that you are trying to make. For example, in The Legend of Zelda, whenever you're using the hookshot, you're using it in a very static fashion. Whenever you equip it, you stop moving when you fire the hookshot. And whenever you stop using it, then you can move. Also, when you're falling, you shouldn't be able to use it. So, and also when you are shooting it, even in the air, you cannot do this behavior. So, it's just little things that make the mechanic feel a lot more polished. For example, if we don't want to move when we are shooting the hookshot, then when here in the event dispatcher, whenever it's going someplace, we can get custom mode, set mode, and instead of custom, put none. This will mean that whenever it's going somewhere, we cannot move. But whenever it returns to us, then we should be able to move again. So again, I need to copy this, paste it, and connect it to returning. And return it to walking. Compile, save, and then whenever we are shooting the hookshot, then we can't move, but it returns to us, and then we can move again. Pretty cool. Now, if we don't want our camera to rotate, and I have not checked if what I did here affects this, maybe? Oh no. Oh, it's working very fine. If we don't want our player to be able to rotate the camera like this, then we need to change the way the inputs are being processed. The inputs are here. Here's the mouse. If you're using a gamepad, you will need to add the same code in this part. but I will show you once. The video is long enough. Okay, so here I will get the child actor component, and from the component I'll get the actual actor, cast it to blueprint hookshot, and I will need to add it here. So I'll use my super plugin. I have added it here. Now, if it's, and we can do something like this. If the hookshot is idle or returning, we should be able to move around my camera, but if it isn't, then we shouldn't. We can get the state here. Get hookshot state, and if this is equal to either the idle or equal the returning, and I'll put here or. I need to move this a little bit, like this. Then, well, here if we can add stuff. If it isn't, we don't add anything. And I will copy and paste the same code here. And, well, organize it with the plugin. Just like that. And now whenever we are in idle and returning, we can move around our camera. But if we're going somewhere, then we can't. Here also, we can't. And the last thing we would need to check is, first, we are able to fire multiple times my hookshot, and also we are able to fire it while we are jumping, and looks a lot weird. So first we need to check the input of the hookshot that I remember it was here. Use hookshot here. I will only be able to fire this hookshot if I'm in idle. So I need to get the state. I need to put equal, and here idle. And also I should be only able to fire the hookshot if I am walking. So here, get movement mode. Here it is, from the character movement component, and equals enum walking. And here I connect the or. Excuse me, this should be and. My bad, because I want both of these conditions to be true. That the hookshot should be in idle and the movement should be walking. And, well, I'll create another if here and connect it to here. Now this go to destination, I don't remember that it was there. Let me put Control F. There it is. Yeah, I removed this. Okay. Now it should be working correctly. If I try to fire again, I can't unless the hookshot is already returning to me. And if I try to jump and fire, I can't also. Yeah, and this is still working. Yeah, pretty cool. And that's all. That's all that I wanted to do with this project. We really did a deep dive of the hookshot mechanic. And we have learned a lot. Really a lot. How to create logic, how to use event dispatchers, how to use the instance static mesh components, how to modify instances on the fly, scale, move, create flows of behavior using states inside the hookshot. And yeah, we have learned a lot. Hopefully, some of it was new to you, or if you already knew how to do that, then at least you got entertained or found some nugget of information that you didn't know about. And yeah, hopefully it was useful to you. With that said, I'll see you in the next one.